So example 6, let profit equal 4AP plus 120P minus 20P squared minus 1/10 A squared P minus 90, where pi is equal to profit, A equals amount spent on advertising. So advertising expenditures are going to be included in our assessment. And P is equal to price charged per item. Maximize profit and state the AP and maximum profit. So what's our objective here? What are we trying to optimize, I should say? We're trying to optimize profit. So focus on what we're trying to optimize. I have too often run into students trying to optimize the wrong thing, which is why I'm making a strong emphasis on this. So what we have here is profit that we're trying to optimize. So I'm going to write down my profit equation. Now I'm going to do my step 1. I'm going to determine the first derivatives of this. So the profit derivative with respect to A. So the first term here, the derivative is going to be 4P. The second term and the third term, there are no A values, so the derivatives would be 0. For our third term here, our fourth term here, I'm going to have negative 1/10 times P, and then the derivative of A squared is going to be 2A. And then for our last term here, it's a constant, so the derivative is 0. So my derivative is going to be 4P minus 2 and 1/10 combined to give me 1/5 AP. Now the derivative with respect to P is going to be, for the first term, I have 4AP, the derivative becomes 4A. For the second term, my 120P, the derivative becomes 120. For the third term, negative 20P squared, the derivative, it becomes negative 40P. For the fourth term, I get 1/10 A squared times the derivative of P is 1. And then for the last term, it's a constant, so the derivative is 0. Okay, so there is the function, the first two derivatives, I should say. I'm going to set these to be equal to 0 is going to be step 2. Step 2, setting these to be equal to 0 and solving for the X and Y pairs, or in this case, A and P pairs. So I have two approaches. One is elimination, one is substitution. What do you suggest we do? Use elimination or substitution? So elimination seems tempting because what we can see here is we've got a 4P, but we've got AP combined here. So this is not linear, and our second equation is definitely not linear. So I would go with substitution. Let's go with substitution. Let's label this equation 1 and this equation 2. So let's start with equation 1. 4P minus 1/5 AP is equal to 0. Do we see a common factor here? We see the common factor of P here, don't we? So what I'm going to do is I'm going to pull out that common factor, P. So P times 4 minus 1/5 A is going to be equal to 0. So either one of these terms is going to be equal to 0. Either one of those is going to be equal to 0. It doesn't matter which one of those terms is equal to 0. But we can solve that this will be equal to 0 when P is equal to 0, or when 4 minus 1/5 A is equal to 0. So moving 1/5 A to the other side, I get 4 is equal to 1/5 A. Multiplying both sides by 5, I get 20 is equal to A. So now I have the solutions P is equal to 0 or A is equal to 20 will make our first derivative, our partial derivative with respect to A, equal to 0. But we have to make sure that it will also work to make our second equation here equal to 0. We have to make sure that it'll work for this as well. Both of these have to be equal to 0. So now I'm going to focus on our second equation. 4a plus 120 minus 40p minus 1/10, I'm just going to write that as 0.10 or 0.1, a squared is equal to 0. So now what I'm going to do is I'm going to examine, we don't sub them in at the same time because this is an or situation, not an and situation. The first derivative is going to be 0 when either p is equal to 0 or a is equal to 0. So what we're going to do is first, when p is equal to 0, so let me put this in a different color. So when p is equal to 0, what does this equation become? We get 4a plus 120 minus 40 times 0 minus 0.1 a squared is equal to 0. So this becomes 4a plus 120 minus 0 minus 0.1 a squared is equal to 0. Now, how do I solve for what a values will satisfy this? It's a quadratic, that's right. I could rewrite this as negative 0.1 a squared plus 4a plus 120 is equal to 0. And I've got the relationship of a quadratic, where my a value is going to be the coefficient for a squared, negative 0.1. My b value for the quadratic equation is going to be the coefficient for a, 4. And my c value is this constant at the end, 120. So doing my quadratic, I'm going to get a, big A, the a we're trying to solve for, is going to be equal to negative b plus or minus b squared minus 4ac, all square rooted, divided by 2a. So that gives me negative 4 plus or minus 4 squared minus 4 times negative 0.1 times c of 120, all square rooted, divided by 2 times negative 0.1. This gives me it gives me negative 4 plus or minus the root of 64 divided by negative 0.2, or negative 20 or 60. So in other words, when p is equal to 0, I have two critical point pairings here that come from p being equal to 0. So a comma p would be equal to negative 20 comma 0 or positive 60 comma 0 as two critical points. And that's only when p is equal to 0. What about when a is equal to 20? So that's what we're going to do now. Next, we're going to look at when a is equal to 20. So we're going to take this equation again and look at when a is equal to 20. So when a is equal to 20, this becomes 4 times 20 plus 120 minus 40 times p minus 0.1 times 20 squared is equal to 0. This gives me 80 plus 120 minus 40p minus 40 will be equal to 0. All of this combines to give me 160 minus 40p equal to 0. I move 40p to the other side. I get 160 is equal to 40p. Dividing both sides by 40, I then get p is equal to 4. So there's a singular solution here when a is equal to 20, p is equal to 40, so I get one more critical pairing. AP would be equal to 20, 4. So I have 3 critical points. So this is another way that we could solve for a system of equations, solving them one by one through factoring instead. This is a really tricky item to isolate. When you look at a combined expression like this, isolating it is going to be really, really tricky using equation 1, because the only way to isolate either A or P, basically the only way to separate when you've got an AP term here is to do this factorization. But then if you factor it, the only way to move it out over to the other side is to multiply or divide by 0. And so that gets to be, you're kind of eliminating one of your solutions when you do that. Where you could have done a substitution approach is by using the second equation. If you took this equation instead, you could have isolated P and then substituted back into 1. You can't do substitution starting with equation 1, but you could do substitution by starting with equation 2. Okay, from here, what you would do is you would do your second derivative test. We will leave it there. The solution is posted for how to go about the rest. I think the sticking point so far has been algebra, so we'll keep the emphasis on the algebra today. But you are not by any means done this question. The last part is that we've got 3, all we've done so far is ascertained that we have 3 critical points. We still have to classify them.